Hello. In this lecture we will look at the different method of utilizing certificates for IKEv1 authentication. We will also take a look at the difference between using PKI authentication and what is referred to as RSA signatures. We will analyze this by looking at the debug, same like we did in the previous lecture. I have the strong swan IPsec configuration file open. In last lecture we went over the first connection, the Sun-Moon connection. Now we will go over the connection named Sun-Moon using RSA signatures. The left subnet is the source network that will be in the tunnel, which is the network behind this side of the connection. This is the file name for the certificate this side will use for authentication. The right value is the IP address of the peer this firewall will reach out to in order to initiate the connection. The auth by is letting strong swan know that this connection will use certificate authentication. However, the certificates utilized is not issued by a trusted certificate of authority. The right ID is used to identify the other side. The certificate provided by the other side has to match the common name of moon.ca.self in the subject name. The right subnet is the proxy ID, the network in the remote side that will be reachable through this tunnel. The auto start tells strong swan to automatically bring up this connection. The IK line specify that IK version 1 will be used. The key exchange as well as the IK and ESP values are self-explanatory. First, let's run IPsec status to see if any connections are up. There is a connection currently in place. Let's bring it down to make sure the logs are only pertinent to the connection we will initiate. Okay, currently no connections are up. If we issue the command IPsec status all, we see what is currently configured as far as connections. There are two connections, one using PKI and another using RSA signatures. If we look at the directory under ipsec.d/certs, we see the certificate file. This is the local certificate that will be used to authenticate to the peer. You can run IPsec list certs to see a list of all certificates seen by strong swan. Here is the local certificate information. If you see here that it's self-signed, meaning that this certificate is not issued by a trusted third party. Here is also the remote site certificate, it is also self-signed. The difference between the two certs is that the local cert private key is located on this system, while the remote one is present in the remote system. If we issue the command IPsec list CA certs, this will show us the certificate of authorities that are trusted by this system. Under the private keys folder, we have the private key file for the local certificate belonging to this side of the connection. So, in a regular configuration with pre-shared keys, we place the key in a file called ipsec.secrets. If you are using certificates, you have to let the system know the name of the private key file. It will be searching for this file under the ipsec.d private key folder. Before we start the debug, I will remove the older log file. I will now tail the var log syslog file and redirect it to the log file as well as run it in the background. This is the reason why the ampersand is at the end of the command. Okay, great. We are ready to bring up the connection. Let's run the debug on the IPsec process. This is using the command IPsec followed by stroke log level any, 4. Okay, bringing up the connection with IPsec up. Connection is successfully established. For the sake of not repeating myself, I will just go over the highlighted difference from our last debug. We'll do some editing to only show the pertinent information. This is main message 1 getting crafted. we see the SPI responder is all zeros. Main message 1 is being prepared. The system is adding the vendor ID's attributes. It is sending message 1. This shows us that the connection is the RSA signature connection. It received the response. Let's skip until we see the authentication piece. Here is message 4 received with the certificate request. It also have Diffie-Hellman key, the nonce and NAT discovery messages. Since StrongSwan is configured with this certificate of authority, the request will always list the trusted roots, even though this session is using self-signed certificate. No surprise here, the same as the last debug. Since the Diffie-Hellman key was received, this side will generate the S-key ID for authentication and decryption. So, we have to remember this is in response to message 4. This side already received the Diffie-Hellman key of the responder, and as it is generating its own Diffie-Hellman key, it can also calculate the master key. This side calculates #I as well. It will hash it with the keys for authentication and encrypt it with the keys of encryption. This means signing it, or creating the signature. Now that all those steps are done, this side will line the pieces up in order to send message 5. As you see here, the fields are the ID, which is cn equals sun.ca.self, followed by the certificate that is used by this side. Then the signature. That is followed by another cert request. That cert request contains a request for certificates issued by the trusted roots. After it receives message 6, it decrypts it. It will decrypt the signature that is sent by the responder. In message 6, the responder sent its own certificate. The main point that needs to be understood here is that this certificate has to be configured locally in the certs folder. This means this site trusts this self-signed certificate. Okay, hopefully this highlighted the differences. See you in the next lecture.